यस, गुड मॉर्निंग स्टूडेंट्स। देखिए, हम बात कर रहे थे इक्विलिब्रियम से रिलेटेड प्रॉब्लम्स पे और हमने एक क्वेश्चन कर भी लिया था जिसमें हमने नॉर्मल रिएक्शन को फाइंड आउट करा था। यस, नेक्स्ट क्वेश्चन लिखेंगे प्लीज। कैलकुलेट नॉर्मल रिएक्शन एक्टिंग on sphere due to inclined planes for the arrangement shown in figure. For the arrangement shown in figure. The arrangement is like this. Arrangement ये है. This angle is 30 degree. This angle is 60 degree. And the sphere of mass 5 kg is lying at this position. This is a sphere of mass 5 kg, let's suppose. The sphere of mass 5 kg. These are the inclined planes. Now, how to deal with such type of problems? देखो, we can easily see the whole system is in equilibrium. Yeah, the sphere of the 5 kg, it is in equilibrium. So sphere is in equilibrium. Is in equilibrium. Now the contact between the blocks and this sphere and this, it is at this position. So the normal reaction is acting at this position. Let's suppose I am taking this normal reaction as Fn1 and this is along this. I am taking it as Fn2 and mg is acting in downward direction if I make its free body diagram. Acting in downward direction, and this is the direction for Fn1. This is the direction for Fn1. ये F1 ले लो आप. This is the F2. Now both will have two components. It has one component in this direction. Another component is in this direction. Similarly, it will have two components. One is along this. Another one is along this. Now, you can easily see this angle is 30. If this angle is 30, then which angle is 30? Look at C. This angle is 90 degree, this angle is 60 and this is 30. Similarly, this angle is 90 degree, this is 30 and this is 60. ये चीज है. बोल सकते हैं? Yes. अब देखो क्या, नाउ रिजॉल्व द कंपोनेंट्स. मैं इसको आपको फिगर को यहां पे भी दिखा रहा हूं. देखो इसमें क्या हो रहा है. दिस इज अ सेंटर. इसके सेंटर के यहां पर लग रहा है M1 F1 और कहीं यहीं पे लग रहा है Fn1 Fn2. It has two components. This is the component, this is the component. It has two components. This is the component and this is the component. And mg is acting in downward direction. And it is at rest. So I have taken it as Fn1, F1 and this is F2. And we can easily see this angle is 60. This is 60 and this is 30. Now if you look at the components of this, that is f1 cos 60. It is cos 60 is 1 by 2, that is f1 by 2. And it is f1 sin 60. This is f1 root 3 by 2. Similarly, this is what? f2 cos 30. f2 into root 3 by 2. And this is f2 sin 30. f2 by 2. Right? So these are the forces are acting on it. अब देखो, if you look at this, so this is in equilibrium. If anything is in equilibrium, then the total net force is 0. Net force is 0. Now, this is the forces are acting in the x direction. These are the forces acting in x direction. So you can take this, let's suppose, इसको आप क्या ले लो? इसको ले लो आप f1 डैश, f3 ले लो, इसको f4 बोल दो, इसको f5 बोल दो, इसको f6 बोल दो. नाउ देखो मैं क्या लिख सकता हूं. फॉर इक्विलिब्रियम नेट फोर्स इज 0, मतलब टोटल फोर्स इन एक्स डायरेक्शन, समीशन ऑफ फोर्सेज इन एक्स डायरेक्शन, it is 0. How many forces are in x direction? There is f3 and f6, f3 and x6. f3 is in this direction. I am taking this as positive I cap, so it is f3 I cap plus this is f6 minus I cap, and it should be 0. It should be 0. तो कितना बन रहा है? f3 is equal to f6. What is f3? f1 root 3 by 2, and this is f by 2. That is f1 root 3 by 2, and this is f2 by 2. मतलब f1 root 3 is equal to f2 आ गया. f1 root 3 is equal to f2 आ गया. Similarly, for summation in y, how many forces are in y direction? The upward force you can take as positive and downward negative. There are 3 forces. मतलब you can take f5 plus f4. f4 plus f5, it is equal to f6. क्योंकि ये डाउनवर्ड है. नाउ f6 कह रहा हूं, mg. What is f4? f4 is f1 by 2, and this is f2 root 3 by 2. That is f1 by 2, and this is f3 root 3 by 2. This is m into g. Right? Now there are 2 equations in between the f1, f2, f1 and f2. There are 2 equations in between f1 and f2, and if there are 2 equations you can solve it. मैं यहाँ पे solve कर रहा हूँ इसको, यहाँ पे solve कर रहा हूँ इसको, देखेंगे. The equations are becoming, the first equation is f2 is equal to f1 root 3. Second equation is f1 by 2 plus f3 root 3 by 2 is equal to mg. Now, what is the value of f2? It is f2 root 3 by 2. It is f2. What is the value of f2? f2 is f1 root 3. यहाँ डाल दो. तो अगर f1 root 3 डालोगे तो it will become 3f2 by 2, 3f1 by 2, and it is f1 by 2. that will become 4f1 by 2, that will become f1, 2f1. 2f1 is equal to mg. So f1 is equal to mg by 2. f1 इधर आएगा, अगर f1 इधर आ गया f1 को यहाँ डालो तो what is f2? √3 by 2 mg. क्लियर है? तो दिस इज द केस. राइट? नेक्स्ट अगला क्वेश्चन देखो. कैलकुलेट टेंशन इन ईच स्ट्रिंग if a block of 30 kg is suspended calculate tension in each string if a block of 30 kg is suspended from them as shown in figure. So this is the case. A block of 30 kg is suspended from it. This angle is 37. We have to calculate tension in each string. देखो, again there are two strings in it. If we make the free body diagram of it, let's suppose the tension in this string is T1. And in this string the tension is T2. Now the block is in equilibrium. So F net force is equal to 0. देखो इसके ऊपर क्या लगेगा. Tension is always a pull force. 30G is acting in downward direction. This is hinged to it. So T2 will act in this direction. If this angle is 37, it has two components. then this angle is also 37, and this is T1. So here also the T1 is acting, right? So these are the forces that are acting in horizontal and vertical direction, and these are the components of this. अगर मैं इसको solve करना चाहूँ, now how many forces are this? This is 37. You know how to calculate the value of 37? हमने पहले भी कर रखा है कि अगर ये एक राइट एंगल ट्राइंगल होता है जिसकी 3, 4, 5 साइड्स है, तो इसके अंदर ये जो एंगल होता है, this angle is called 53, this angle is called 37, this is 90. So if someone asks me to calculate the value of 37, that is cos 37, 4 by 5. What is sin 37? 3 by 5 and so on. Right? Now, these are the forces. This will become T2 cos 37. Cos 37 is 4 by 5. So, 4 by 5 T2. This is T2 sin 37. Sin 37 is 3 by 5. So, it is 3 by 5 T2. And this is T1. Now, net force is 0. The summation of Fx is equal to 0. How many forces are in x direction? There are two forces. This is along the positive x-axis. This is along the negative x-axis. So, you can say it is 4 by 5 T2 I cap plus T1 minus I cap is 0. तो क्या निकल गया है? T1 is equal to 4 by 5 T2. और यहां से क्या निकल गया है? y एक्सिस से समीशन ऑफ Fy is 0. अगर समीशन 0 है, देयर हाउ मेनी फोर्सेस आर इन Fy? दीज आर टू फोर्सेस. दिस इज अपवर्ड फोर्स, तो उसको लिख लो पॉजिटिव. प्लस 30G minus J cap is 0. So what is the value of T2? T2 is 30G into 5 by 3. This will become 100 into 5, 500. 500 Newton. If T2 is 500 Newton, so what is T1? 400 Newton. Is it clear to all of you? हाँ जी, clear है सबको? So in this way we can solve this type of problem. Clear? एक क्वेश्चन और देखते हैं इसी के ऊपर बेस्ड. Two blocks of 10 kg and 30 kg are suspended by 4 strings as shown in figure. calculate tension in each string. These are the blocks, and the angles are this angle is 30 degree. देखो अभी इधर यस, अगर मैं 10 kg का फ्री बॉडी डायग्राम लूं, blocks are in equilibrium. मान लो इसमें टेंशन T1 है, इसमें T2 है, इसमें T3 है, और इसमें T4 है. This is 10 kg. इसके अलावा इसका 10G लग रहा होगा नीचे. Now this is T1, this angle is 30 degree. This is T3 and this angle is 37 degree. Similarly, if this angle is 37, then this angle is also, this is 45, this is also 45. देखो क्लियर है सबको. अब देखो इसके क्या क्या कंपोनेंट्स हैं. अब डायरेक्ट लिखूंगा, व्हाट इज T3 cos 37? T3 cos 37. T3 cos 37 is T3 into 4 by 5. So it is 4 by 5 T3. This is T3 sin 37. That is 3 by 5 T3. Now, this is T1, this is T2. T2 का cos 30. Cos 30 is root 3 by 2. So root 3 by 2 T2. T2 का sin 30. T2 by 2. Clear? Same इसमें देखो. It is having components. Cos what sin 45. T4 by root 2. It is cos 45. T4 by root 2. Similarly, this is T3. T3 का sin 37. Sin 37 is 3 by 5. T3 का cos 37. Cos 37 is 4 by 5. Now, both the blocks are in equilibrium. If both blocks are in equilibrium, then net force should be 0. देखो, how many are in the forces x direction? This is T1, T2 and T3. So these are in positive x, this is negative x. So I should write T2 by 2 plus 3 by 5 T3. That is equal to T1. First equation. And if we look at the vertical motion, there are how many forces? 1, 2 and 3. This is in upward direction. So I can write 3 root 3 by 2 T2 is equal to 100 plus 4 by 5 T1. Right? If you look at this side, four by 5 T3. How many forces are in x direction? There are two forces in x direction, this and this. तो क्या relation बन रहा है? 3 by 5 T3. This is positive, this is negative. Net force 0 होनी चाहिए. T4 by root 2. ऐसे अपवर्ड में दो फोर्स एक डाउनवर्ड में 4 by 5 T3 now how many equations are there? There are total 4 equations and 4 variables. अब हमें इसको सॉल्व करना है. देखो आज सबसे पहले किसी दो की वैल्यू निकाल लो. फर्स्ट इक्वेशन इज इन बिटवीन दिस इज T2 एंड T3. आप इन दोनों को सोल्व कर लो सबसे पहले, T3 और T4 को. तो व्हाट इज द वैल्यू ऑफ T3? T3 इज 5 T4 बाई रूट 2. T3 की वैल्यू डाल दो 5 T4 बाई रूट 3 इंटू 2. What is the value of T3? या T4 by root 2 को देखो क्या है डायरेक्ट. T4 by root 2 is 3 by 5 T3. 3 by 5 T3 plus 4 by 5 T3. 7 by 5 T3. 300. So what is the value of T3? 1500 by 7. अगर T3 इतना है, आपको समझ आ गया ना, यहाँ से T4 की वैल्यू इसमें डाल दी, T3 को यहाँ डाल दो. T3 is 1500 by 7. कटिंग करेंगे तो 500 बचेगा. 5 into 3 is 1500 by 7 बचेगा. 900/7, तो T4 कितना आएगा यहाँ से 900/7 into √2 न्यूटन। नाउ T3 की वैल्यू यहां डाल दो, यहां डालेंगे तो कितना बचेगा, डायरेक्ट कटिंग करेंगे हम वहां से तो बचेगा 100, 400 बचेगा, 5 से कटिंग करेंगे 3, 12, 1200/7 बनेगा। 1200/7 का एलसीएम लेंगे कितना बनेगा 700 + 1200 1900/7 बनेगा, और इसको उधर लेके जाएंगे तो 3800/7 बनेगा। √3 से डिवाइड करेंगे तो T2 कितना निकलेगा 3800/7 √2। अगर T2 इतना निकला है, T2 की वैल्यू को यहाँ डाल दो और T3 की वैल्यू डाल दो, यहाँ से आपका क्या कैलकुलेट होगा T1। आप इसको खुद करेंगे T1 को कैलकुलेट। इज इट क्लियर टू ऑल ऑफ यू? समझ आया सबको? लिखो इसको। हाँ जी, कर लिया आपने नोट के? देखो नेक्स्ट, नेक्स्ट इज एक्सेलरेटेड ब्लॉक्स। अब हम सब एक्सेलरेटेड ब्लॉक्स करेंगे। जैसे देखो क्वेश्चन, calculate acceleration of block as well as acceleration of block as well as normal reaction between surfaces if a force of 5 mg is exerted on mkg block placed on smooth surface. Smooth surface as shown. This is the figure for it. This is the smooth surface. The block of m kg and a force of 5 mg is acting on it at an angle of 37 from horizontal. So we have to calculate the acceleration and the normal action between the surfaces. So you will just see now the blocks is not in rest, it is not in equilibrium. So you can easily see if we resolve its component, it has two components. One is the component along this 5 mg cos 37. What is cos 37? Cos 37 is 4/5. This will be 4 mg. There is another component which is in vertical direction. This is 5 mg sine 37. Sine 37 is 3 by 5. mg. And this is the smooth surface. Now, other than this, there is a force mg is acting in downward direction, and there is a normal reaction exerting on it by the surface. If we look at in vertical direction, so in vertical direction there are three forces. In vertical, F is 0, because in the vertical direction net force is 0 because it is at rest. Of course, in x direction, because it has this component in this direction, so it will start moving in this direction with some acceleration a. It will start moving with an acceleration a. Fy को 0 करूँगा. These forces are in upward direction, it is in downward direction. So it means Fn को positive लूँगा. Plus 3 mg. इसको 5 mg की जगह एक छोटा सा चेंज कर रहा हूँ. इसको 5 mg की जगह सिर्फ mg लो. 5 mg की जगह सिर्फ mg लेंगे तो इट विल कम आउट टू बी 4 by 5 mg, and it will come out to be 3 by 5 mg. Right? Now the three forces are 3 by 5 mg minus mg. What is the value of normal reaction? Normal reaction is mg minus 3 by 5 mg. mg minus, that will be how much? 2 mg by 5. By 5 mg. And in horizontal, if we solve, it has an acceleration A. अगर इसकी acceleration A है horizontal में, तो we can write कि all the forces summation, it is m into A. Now how many forces are in this direction? There is only one. That is 4 by 5 mg. This is m into A. What is A? It is 4 by 5g. Right? So in this way we can solve it. Next, next is motion of connected blocks. जैसे लिखेंगे क्वेश्चन, two blocks of masses 5 kg and 3 kg are connected and a force of 20 Newton is applied. Calculate contact force between them and acceleration of each block. ये इसकी फिगर है. This is of 5 kg and 3 kg and a force of 20 Newton is applied on it. So we have to calculate the contact force between them and the acceleration of both blocks. Now we know this thing, when the force is applied, the both blocks will start moving together with an acceleration, let's suppose A. So for the solution of it, you can make two free body diagrams. You can make one of the free body diagram, that is a combined free body diagram. Combine it will act as 5 plus 3, 8. In the horizontal direction, there is only one force is applied. Because the contact force between them, it will become the internal force. And it is moving with A. If we look at the vertical, so there is 8G is applied in this direction. And there is total contact force. Normal action is applied in vertical direction. This is Fn. Now, if we look at the horizontal only, this is equal to M into A. So it is A. 20 by 8. 5 by 2. Meter per second square. If you want to calculate total normal action, so from the vertical, Fn will become equal to 8G. 8G. If you draw any other free body diagram, like let's suppose of 3 kg, from the 3 kg there is only one force is exerting, that is 5 kg on 3 kg. There is only one force, that is the normal reaction Fn F1. And इसके अलावा this is also moving with A. There is 3G is acting in downward direction. Normal reaction is upward, that is Fn1. So from the horizontal you can write F1 is equal to 3 into A. What is the value of A? 5 by 2. That is 15 by 2 Newton. And if we look at the vertical, we can write directly Fn1 is equal to 30. You know, here it is acting, that is Fn1. Here it is acting, that is Fn2. And Fn is the summation of Fn1 plus Fn2. So we can write also Fn is equal to now what is Fn? 8. What is Fn1? 8G 80 30. Right? This is the approach to do such type of problems. Clear है? लिखेंगे सब लोग इसको.